How these advancements in technology, how those influence your approach to design and analysis? Maybe they have stricter structural requirements, or how did that affect it in terms of the growth of
So,
technology?
as far as structural requirements are concerned, those are mostly dictated by the standards and codes used in the industry, which are updated every 4 or 5 years. But like the technology itself, like the 4G or 5G, and the growing demand for connectivity, the equipment which the carrier or the customer is putting on the tower, they have become bigger and heavier.
Did you know that the global demand for telecommunication towers is skyrocketing with projections showing over 12% annual growth? These structures are the unsung heroes of our connected world, powering everything from 5G networks to emergency communications. But as connectivity needs to evolve, so do the challenges of designing, maintaining, and upgrading these vital structures. In this episode, I'm joined by Sudarshan Kasera, PE and Senior Project Engineer at Crown Castle, to deep dive into the ever-evolving world of the telecommunications industry. We'll explore how advancements like 5G are reshaping structural requirements, the complexities of tower modifications, and the critical role engineers play in the industry. Whether you're curious about the types of towers out there, the software and standards driving these innovations, or the future of the telecom infrastructure, this conversation will give you a front row seat to the intersection of structural engineering and cutting-edge connectivity. I'm your host, Matt Picardle, and this is the Structural Engineering Channel. Sudarshan, thanks so much for joining us. Can you tell us a little bit about yourself, what you do on a daily basis, and how you became a senior project engineer at Crown Castle?
Thanks, Matthew. I'm excited to be here. I'm originally from India, where I earned my bachelor's degree in civil engineering. After working for 2 years in India, I moved to the United States to pursue my master's degree. My career in the telecommunications industry began in Dallas, where I worked for 2 years before joining Crown Castle as a design engineer in January of 2017. At that time, I already had 4 years of experience as a structural engineer, so I focused on advancing my career and passed the PE exam in October of 2017. This led to my promotion to project engineer in 2018. With continued experience, growth, and added responsibilities, I was promoted to senior project engineer in 2021. In my current role, my daily responsibilities vary widely. They include conducting tower analysis, reviewing and approving structural engineering reports prepared by other engineers, and assisting internal partners with engineering and maintenance related questions. One of the challenges in this industry is aging infrastructure. So, a lot of my time is spent on providing resolution on maintenance related items. I also help the internal partners addressing engineering comments from the jurisdiction to help obtaining the building permit. So my goal is always to provide effective solutions to address issues and ensure that the structural integrity of the towers are maintained.
Yeah, and what I know for me personally, I've never designed telecommunication towers as a structural engineers. What types of telecommunication towers do you work with, and what are some of the structural challenges that come with it?
So I work with various type of telecommunication towers, mostly all which exist, including monopoles, self-supporting towers, guide towers, and monopoles are typically single pole structures that are space efficient and widely used in urban areas. One key challenge with monopoles is ensuring stability under high wind loads and seismic loading, because most of the loading is like at the top of the tower or towards the top of the tower. So that is a challenge. The other kind of structure is self-supporting towers. These are freestanding lattice towers used in diverse environments that can range from urban to rural. This can have varying configurations such as different kind of bracing systems, leg types, number of sites, typically 3 or 4. These towers have a lot of connection points, so analyzing and designing the connection points can sometimes be challenging. Now, the third kind of tower, which is more prevalent, is guy tower. These are tall, slender structures stabilized with guy wires. Those are like steel wires used to stabilize the tower.
Oh yeah.
Their primary challenge involves analyzing and maintaining tension in the guy wires to resist dynamic loadings. like wind and ice. So there is another category of towers within these. These are called concealed towers. These are towers like which you can see around you, but you'll not notice these are telecom towers. So this can
Oh,
very
yeah.
these are like trees. This can be tree-like structures like monopine, monopalm, flagpole, clock towers, church steeples, even far rocks on mountains. So the unique challenges with these concealed towers are their shapes and size, and they like have a different loading profile. So those are the challenges which the concealed towers have. So yeah, mostly all the tower types that are available in telecom industry, I have worked with them, including concealment towers.
Gotcha. Yeah, and these telecom towers, like the importance of them, they essentially provide us internet, or is that right?
Yeah, partially internet and phone connectivity because
Okay,
our customers are all the big carriers in the US like AT&T, Verizon, T-Mobile, etc. So they put on their equipment on the tower to provide connectivity to the public.
gotcha. And for the with the advances in technology, and I know we're like at 5G now, and it's always evolving with telecommunications. And how have these advancements in technology, how have those influence your approach to design and analysis? Maybe they have stricter structural requirements, or how did that affect it in terms of the growth of
So
technology?
So as far as structural requirements are concerned, those are mostly dictated by the standards and codes used in the industry, which are updated every 4 or 5 years. But like the technology itself, like the 4G or 5G and the growing demand for connectivity, the equipment which the carrier or the customer is putting on the towers, they have become bigger and heavier. So that increases both the structural demands on tower and the complexity of their design and analysis. So one challenge in this industry again is due to aging infrastructure. The demand is toward optimizing existing structures rather than building new ones, especially in urban and high density areas where space is limited. So retrofitting has become a critical part of the industry, required detailed structural evaluations to access the capacity of older towers to support modern loadings. So that's one challenge from 5G. And so basically with this heavier loading and uh, more bigger antennas, what has happened is there are more retrofitting. And now there are tools available like finite element modeling, which we use to model the tower and then apply all the loading to get the results. And if any members or part of the tower is overstressed, then we will modify them. So these advancements have significantly influenced my approach to design and analysis. I now focus on integrating innovative analysis techniques such as like nonlinear analysis and wind simulation to ensure the tower meets the current and future demands from these loadings.
Yeah, and I know I mentioned previously I work mainly on building design. I know there's a different code for telecommunication towers, right? What are those industry codes and standards?
So the most important code for telecommunication tower analysis and design is TIA 222. TIA stands for Telecommunications Industry Association. So this is the primary standard for structural design and analysis of telecommunication towers and antenna supporting structures. It provides detailed requirements for wind, seismic, and ice loading, as well as guidance on structural capacity, foundation design, and maintenance of the tower. In addition to this, uh, we use International Building Code. Basically, the IPC sets the general framework for building safety, including structural integrity, material reuse. Telecommunication towers must comply with IBC requirements as part of broader integration into infrastructure system. Now, TIA pulls a lot of formulas and calculations from uh, codes that are prevalent in building industry, such as AISC, ASCE, AWS, and we also have to follow the state and local codes. Like if there are amendments made, especially for city of LA, they have their own thing, and there are a lot of amendments to IBC which we have to follow. So yeah, basically the most important code is TIA 222, but then we have to follow IBC and other related codes as well.
And I know you mentioned some of the structural analysis tools. what type of tools do you use for these telecommunication towers, and how have they advanced and throughout the years?
Again, for telecommunication towers, one important tool we use is TNX Tower. It is made by Tower Numerics, and so the this is the most used software because of it is very user friendly for tower analysis and design. You can model the different configuration of self-supporting towers, monopoles, guide towers within the tool. The user input and loading input is pretty easy. In addition to TNX Tower, we also use Risa 3D and StatPro. So Risa 3D and StatPro are more versatile softwares where we can model complex part of the tower, or if the tower is heavily reinforced already and TNX is unable to handle that, so we will model that part in Risa 3D or StatPro. Sometimes for seismic analysis, we would use Risa 3D. In addition to this, we use MathCAD and Excels for engineering calculations and creating our reports. So that helps in formulating all of. So we'll take the TNX output and then use MathCAD and Excel sheet to check the anchor rod, foundations, and base plate, which cannot be done in TNX, or it TNX doesn't handle it very well. Let's say that.
Yeah, it's like essentially engineering, right? We use different types of software. We'll get into the spreadsheets,
Yeah,
different types
exactly.
of software.
Yeah.
Like, can you walk us through your approach in design modifications of new design, or maybe a retrofit of a telecom tower, and maybe share an example project?
Sure. So, some of the instances where tower may require modification is additional loading from the customer or bigger equipments that comes on the tower, or maintain. It could be maintenance related, like if the tower is close to a coast and it sees a lot of moisture and salt continuously, which can result in corrosion of steel members. And sometimes environmental factor would be a concern, like hurricane, earthquakes, or even fire. So, when designing modifications or reinforcements for telecom towers, my approach involves a detailed analysis of existing structure first and know the capacity of the structure and the members which are overstressed. And then we take the new loading, do the load analysis, apply that loading to the tower in the TNX software or any external software we are using. After getting the results, we would know what part of the tower is overstressed or what members are overstressed. Then we will work on reinforcing those members. We may replace the member. We may reinforce the member by adding more steel. If it's a monopole tower, we would use flat plates on the surface of the tower and bolt it or weld it as required to reinforce them. So these are mostly the design approaches we take. We first get the existing capacity, then we apply the new loading, and then we will get the overstressed components, and then from there we would reinforce the member as needed. So this is sometimes an iterative process, because if you're adding more steel to the tower, suppose the tower was failing from maybe at elevation 40 feet to 50 feet, and you're adding more steel there, that will also increase the weight and add more wind to the tower. So it may result in more failure below that level. So then it's an iterative process where you reinforce the tower in such a way that you are adding steel to reinforce the whole tower, and it meets the structural compliance with the new code.
Yeah, like a iterative process, like you were saying, where you add something to fix it, but then there's more surface area for the
Yeah,
wind. Now we
exactly.
gotta let's look at it again to make sure everything works.
Yeah. So
And
yeah, I was just saying, one of the complex projects that I have worked on is, it was like a tower again close to proximity of the ocean. So the challenge there is it sees a lot of moisture and salt throughout its lifetime. Even though we have a robust maintenance system where we inspect our towers every year or two, they get corrosion, a lot of it. And reinforcing these is very difficult because first we have to assess the amount of damage or rusting on the tower. So we have to typically we'll send a crew to do a tower mapping. They will send a report with all the rusted members and the amount of rusting on the tower. From there, we would take that rusting into account, model the tower members accordingly, and see if what is overstressed. And again, from there, we would either replace the members which are heavily rusted, upgrade the connections, or add more steel to make the tower stable again and in compliant with the current code.
Yeah. And for I'm just curious from an overall perspective, is most of the analysis, because you mentioned different types of software, is most of the analysis essentially just typical, code design, or do you get into the nonlinear time history analysis types of deal, or is it?
We
Yeah, I guess
don't
what's
get
the range of the complexity?
Yeah, we don't get into the time history analysis, but mostly non-linear, and
Ah,
we do some dynamic analysis on guide towers because they are supported with guide wires. And for seismic analysis, we would get into all those we would follow ASC 716 for the time spectra and everything, and then we'll analyze accordingly.
yeah, depending on where the location is, right?
Location is, yeah.
And what about because I know you're mentioning structural parts, but I mean, a telecom tower is more than just structural. What is it like working with different types of disciplines? I'm guessing there's electrical engineers at the very least, contractors. What's that process like?
So typically, I personally do not collaborate with a lot of mechanical engineers. I think in the industry, each engineer's role is well defined. So whatever loading we need from electrical engineers or mechanical engineers, either it is provided in the drawings or we get it from the customer. So suppose on a telecom tower site, there is a generator proposed or a battery cabinet. So we'll know the dimension of the generator and the weight of the generator and the battery cabinets, and then we'll use that to design the concrete pad or steel platform as needed to support them. On the tower itself, the electrical part is, of course, electrical earthing that is done by the electrical engineer, and there are cables which goes for the customer. So customer will provide the size of the cables and the number of cables they are proposing. So we will add that as a loading in our tower analysis to get the results. But we do collaborate a lot with general contractors because anytime a tower goes into construction or retrofitting, there will be structural drawings, structural reports. So we will clarify any concerns they have in the design or drawings. We will address requests for more information, RFIs from construction site. Suppose they want to use a different grade of material because of availability in the market or a different type of material, then we will review that and approve it as needed. So those are the typical collaboration with GCs. On some projects, we will collaborate with GCs before starting the design because if the design is complex and we can foresee some constructability issue, we will involve a GC to see what materials are available in the market and the site has some constraint if they can work with bring in their equipment to construct the design or not. So we will work with them before and during the design phase to make the construction process more easy.
Gotcha. Yeah, and what about, for my curiosity, are there things that maybe you think maybe typical building engineers might not know about some of the challenges of telecommunication towers? I'm guessing like maybe vibrations or maybe the wires that are sagging. Are there strict requirements on that with the code and whatnot?
I mean, there are, as far as wire sagging, there are limitations in the code. Like for guide wire, there are certain limits the guide wire should be tensioned to, and within that, it can vary within certain limits. So that is another one thing that people working in buildings wouldn't know because that is very specific to TIA. Similarly, the deflection of the tower itself at the maximum deflection which the tower can see, that is also specified in TIA. So we have to follow that. Like we do all the analysis and design, and if it doesn't meet deflection criteria, then we have to start again, like either reinforce the tower or do something about it. So deflection is one thing, and then wire tension in the guide wire is another thing. And then there is fatigue analysis, which is not which is done in the building industry, but not much. Now the recent upgrade in TIA, that is revision I, that has introduced fatigue analysis in the tower base section. So that is something unique to telecommunication towers. I would say not very unique because it's already done in light poles and Aster, but it's something not unique to buildings.
Yeah. And what about, yeah, I'm just going off of my building background because I mean, that's what I know. So I'm just curious about how the other structural engineering disciplines are. What about like the importance factor? Because I know for buildings, right, hospitals or critical infrastructure needs a higher, essentially a higher factor of safety. Is it the same thing with telecommunication towers? Are some towers way more important than others, or?
Yes, it is. So typically what TIA says is if a tower is within the fall zone or a structure within the fall zone of a tower is a high risk structure. Like if a tower is close to a hospital or police station or fire station, then we have to design or analyze the tower to the importance factor of that structure. And
Ah,
sometimes the tower itself can carry, emergency equipment, which is very important during emergency, like calling 911 or getting help. So in that case, if we have that information from the customer that the tower is supporting emergency equipment and there is no redundancy in that area, and this is the only tower that will be supporting the emergency situation, then we have to design those towers with higher importance factor. So basically, it's the same. We have risk category 1, 2, 3, and 4, and we use the importance factor accordingly.
oh, cool. And what do you see in the future? So, with the trends in telecommunication technology, do you think it's going to affect the structural engineering field in any ways? Or is it just going to get bigger and heavier? What do you foresee the future is?
I think equipments are already bigger. So there is a tower, and then add when we add the antennas, there is a mounting system which is installed on the tower. So those mounting systems have become heavier, and antenna itself have become heavier. So that is pushing the limits. So retrofitting is already a big thing. I think the trends that will go is towards more sustainability. Like now we are already seeing like future towers may incorporate renewable energy solutions such as solar panels for providing energy to the equipment, especially in rural areas where electricity may not be there, or like they are using generators, so they might use solar panels. Now a question remains if they will install the solar panels on the tower or at ground level. Either way, structural engineers will be involved to support them. Similarly, now we have also seeing digital twin technology, where digital twins are basically virtual replicas of physical towers that allow real-time monitoring and analysis. So using
Oh,
IoT sensors, engineers can track structural performance and detect early signs of wear and damage. So these sensors cannot be provided throughout the tower because of the cost involved. So they are typically provided like maybe towards at the base of the tower so that any welding is cracking or anything is happening, we would know beforehand. It's not used prevalently now, but that is something I think that will be important in the future. Similarly, automation in structural analysis and inspection is already happening. Like automation of some steps, how structural analysis and design is conducted is like we can focus more on engineering or complex part of engineering and creating the report after everything is done that can be automated. So some companies are already adopting it, like reports are generated automatically after all the engineering is done. Similarly, drones equipped with advanced imaging and LiDAR technologies are being used for tower scanning that provides a 3D view of the tower to us, and we can see each and every member and component. That helps a lot in analyzing the tower and knowing the state of the tower.
yeah, I imagine with the drones, right? It
Yeah,
must be a pain to climb up there or even get up
yeah,
there to see what the status is.
yeah. Until like 2, 3 years ago, that's what. Even now, we use a lot of tower mapping that are climb mapping, and that is what is required by TIA. You have to do climb mapping every 5 years or 7 years, so that before the maintenance of the tower. There is ground-based inspection almost every year or every 2 year, depending on the type of tower. But then ground-based mapping would can give us only certain information if you're taking a photo from the ground. Oh, so digital like scanning, tower scanning, or drones have changed that. Now we just do a drone scan of the whole tower and get the state of the tower.
Oh, cool. Yeah.
Yeah.
And you I know you mentioned the sensors too. So would that look like they put sensors on the tower, and would that be a way to measure maybe wind blows or there's an earthquake, you can kind of see how the structure vibrates and see if there's any damage.
Yeah, that is what is expected. Like I said, they have not implemented all those technologies now because there are way to measure stress and strain. I know in bridge industry they already use those sensors to measure the stress and strains on bridges during times of earthquake or wind. So the sensors we have used sometimes is like for if there is any what do you call any activity within our tower site, someone is trespassing, someone is opening the door, so
Oh,
our knock system will get a notification that the door was opened. So we have implemented that in some towers, not all the towers sites. So that's what I was talking about. Like, but like you mentioned, that IoT sensors can expand to tower itself, where if there is a high wind event or high or an earthquake event, we will know what how it's impacting the tower or if there are any cracks in the welding or not. Like basically based on stress and strains, we can know those things.
yeah. Yeah. And do you have any final piece of advice for structural engineers looking to either get into the telecommunication industry or excel in it? Because I know it's more of a unique niche, so it's cool to get more people that are interested in it, that knowing that there's a telecommunication industry as well.
Yeah, like you said, this is a niche industry, and we do not learn a lot any of it as part of our study at school. So you learn a lot at job. I would say a strong foundation in structural engineering is important. Like deepen your understanding of load analysis, steel design, and foundation engineering, as these are the critical part for designing a safe and reliable telecommunication tower. Now, familiarizing yourself with the code like TIA 222, which we don't study in school again. So, you learn a lot at work when you are actually doing this job. So, you learn a lot. I would also say, like, embrace the technology and new tools that are available to you, like, uh, like learning TNX Tower, ESA 3D, and MathCAD, and stay updated with any advancement in digital tools like drones for inspection and digital twins for real-time performance monitoring. In this industry, I think adaptability is key because with the new technology of the carrier or the customer, the towers also have to be upgraded every time. So you have to adapt and use your like problem solving skills because you have to design retrofits. Without that, you cannot work in this industry. So you have to use your problem solving skills to do them, and you have to be innovative. And sometimes the site there are a lot of site constraints, or the tower has already has 2 3 generations of modifications, and you have to add another one. So you have to
Yeah.
be innovative there. So I would say continuously you have to learn and network if you want to get into this industry. There are a lot of opportunities. I think TIA has does conferences, and they have done I think few events here and there where you can go and network with telecommunication people and get into the industry. So my final thought would be like stay curious and embrace the challenges it provides. It's unique industry and not a lot of people are there in telecommunication. So there is a lot of opportunities.
Yeah. Thanks so much for that advice, Sudarshan. I appreciate you coming on and talking about telecommunication towers and structural engineering that goes behind it. I was always personally curious about those because, like you were saying, I've seen all of these types of telecommunication towers. I look at them and I always wonder about the the structural engineering behind them. So I appreciate it.
So typically I never used to notice these towers until I started working in
Oh yeah,
telecommunication.
I've seen the hidden ones, like the ones that are trying to like be disguised as a tree.
Yeah, and City of LA has a lot of them because there are stricter zoning requirements and aesthetics plays a big role. So City of LA, San Jose, they have like a huge requirement for these concealment towers.
Oh wow, yeah. There's probably a good amount of them that I don't even know are
Yeah,
telecommunication towers.
yep.
Yeah, it's been a pleasure having you on.
Thank you for having me today. And I'd like to thank you and your team for setting this up. Greatly appreciate it.
Absolutely. I hope you enjoyed the episode today. We'd love to hear your feedback, comments, and or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources or websites mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcast. Until next time, we wish you the best in all of your structural engineering endeavors.